Hi everyone, in this video we look at an example where we're asked to graph a function involving multiple transformations, involving a stretch and a translation. So the example says, on the grid below, graph the function f of x is equal to 1 over 2x plus 1. The first thing that we have to do is identify what the parent function is. And the parent function here is 1 over x. The next thing that we have to do is we have to think about what transformations have been applied to the parent function. So how can I get f of x by rewriting it in terms of g of x? So there's actually two ways to do this, but I can rewrite f of x as 1/2 g of x plus 1. If I actually substitute g of x, because g of x is just 1 over x, I would get 1/2 times 1 over x plus 1. And if I multiply here, I get 1 over 2x plus 1. Another way to rewrite f of x in terms of g of x would be to say that f of x is equal to g of 2x plus 1, which would be equal to 1 over 2x plus 1 if I substituted 2x in for g of x. So you can see that there's actually a couple different ways to, or there's two different ways to think about f of x in terms of g of x here. Let's now think about what transformations have been applied to the function g of x in order to get f of x. Well, here we can see that if let's use this form for f of x. We can see that the factor 1/2 g of x is a vertical compression by a factor of 1/2. And when I add 1 to g of x, that is a vertical transformation or vertical translation up 1 unit. So let's think about a mapping rule for the points on g of x. If x comma y is on g of x, then x comma 1/2 y plus 1 will be on the graph of f of x. Remember that you always have to perform stretches, reflections, and compressions before you perform translations. So that's why I'm multiplying the y value of g of x by 1/2 before I add 1 to it. I have to perform reflections, stretches, and compressions before translations, because I have to follow BEDMAS. So let's go ahead and we'll use this mapping rule to get the key points of g of x, to get the key points of f of x from the key points of our parent function, which is 1 over x. So if -2 comma -1/2 is on g of x, well then -2 comma, let's see here, how do I get the y value of f of x from this y value here? Well, I have to multiply the y value of g of x by 1/2 and then add 1. So -1/2 times 1/2 is -1/4. -1/4 plus 1 is 3/4. So -2 comma 3/4 is on the graph of f of x. For my next point, -1 comma -1 maps to -1 comma, let's think about what the y value would be. Well, I have to multiply -1 by 1/2. -1 times 1/2 is -1/2. -1/2 plus 1 is just 1/2. Let's now transform this point. The x value stays the same because we're only doing horizontal or vertical transformations here. There's no horizontal transformations. The y value would be 1/2 times -2, which is -1. -1 plus 1 is 0. Next I've got 1/2 comma, well, let's see here. 1/2 times 2 is 1. 1 plus 1 is positive 2. Next I've got 1 comma 1/2 times 1. 1/2 times 1 is 1/2. 1/2 plus 1 is 3/2. And then I have 2 comma 1/2 times 1/2. 1/2 times 1/2 is 1/4. 1/4 plus 1 is 5/4. So these are the key points on f of x. Now let's sketch the graph of g of x, and then let's think about how we're going to come up with a process for graphing f of x. If I think about the parent function g of x, it has a vertical asymptote. It has a vertical asymptote at x is equal to 0. It has a horizontal asymptote at y is equal to 0. And it's got key points here, 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 and here, and here. The graph should look something like this as... Oh, whoops, sorry. That is wrong. I should really look at the points that I've got written out here. Okay, so we've got a point at -1, comma, -1. -2, comma, -1/2. -3, comma, -1/3. -4, comma, -1/4. It should have a key point here, a key point here, and a key point here. And you can sketch a smooth curve through all those points. And then I've also got key points here, here. Whoops, I should have a key point at 1/3, comma, 3, and 1/4, comma, 4. I should have a key point at 2, comma, 1/2, 3, comma, 1/3, and 4, comma, 1/4. So all of these points are on the graph of g of x, and that's my parent function. So that's the graph of 1/x. If you're unsure how I got these points, you should check out my previous video on graphing graphing the 5 parent functions. So in order to graph f of x is going to have a similar shape to g of x, only it's going to be a vertical compression by a factor of 1/2. It's also going to have a vertical translation 1 unit upward. So I have to think about where the asymptotes are going to be on f of x. On the graph of g of x, I had a vertical asymptote x is equal to 0 and a horizontal asymptote y is equal to 0. On f of x, I'll have this horizontal asymptote is going to be shifted 1 unit upward. So my asymptotes are going to be y is equal to 1 and x is equal to 0. So let's start by sketching out the asymptotes. So my horizontal asymptote is y is equal to 1. My vertical asymptote stays the same. It's still x is equal to 0. Now let's sketch the key points. Well, I've got a point at -2, comma, 3/4. -2, comma, 3/4 is here. I've got a point at -1, comma, 1/2, which is here. I've got a point at -1/2, comma, 0. -1/2, comma, 0 is here. And then I can kind of think about where all the other points are going to be. So I know that my curve should pass through these 3 key points. But then as x goes to 0 from the left side of the graph, this graph is going to get closer and closer to the asymptote, which is x is equal to 0. And then on this side of the graph, when x goes to -infinity, or as x gets further and further in the negative direction, this graph is going to become closer and closer to the horizontal asymptote, which is y is equal to 1. So the graph should look something like that. Let's go ahead and we'll plot our other points. So I've got 1/2, comma, 2, which is here. I've got 1, comma, 3/2. So 1, comma, 3/2 would be here, and I've got the point 2, comma, 5/4. So 2 comma 5 quarters is, let's see, 2 comma 5 quarters is here. So now we can sketch a smooth curve through these points, and I can also see that as x gets larger and larger, my graph should get closer and closer to the horizontal asymptote, which is y is equal to 1. And similarly, as x gets closer to 0 here, my graph is going to approach the vertical asymptote. So my graph should look something like, well, let me resketch that. It should look something like this. And you can see that what we've done here is we have shifted the graph of g of x up 1 unit, but also compressed it vertically by a factor of 1/2. So we've compressed all the points vertically by a factor of 1/2 and shifted it up 1 unit. And we have to perform vertical stretches before translation. So always perform stretches, compressions, and reflections before any translations. So this is the graph of f of x.